When welding aluminum, the biggest challenge is managing heat, not because the aluminum melts at a lower temperature than the steel, but because the aluminum transfers the heat around the panel faster than the steel. So the challenge becomes getting heat into the panel, but not too much heat. If there's too much heat, the heat effect zone will weaken the repair area. When making an aluminum butt joint with backing, joint bridging is critical for managing heat transfer. Joint bridging involves a backing that touches all panels being welded. By doing this, the heat can transfer across all panels, reducing the chance of an area getting too hot and burning through. When making an open butt joint, root gap is critical. Root gap is the space between the two panels along the seam that is being welded. If it is too tight, the panels may warp. If it is too wide, it becomes challenging to bridge the gap with the weld puddle, and burn-through may occur. Run-on and run-off tabs can be used to help avoid the effect of a cold start and a crater in a weld bead. In areas where space allows, run-on and run-off tabs can be attached to the start and end of the weld area. Using these tabs, allow the weld to be started before the joint and allow the weld to end after the joint. Run-on and run-off tabs are small tabs that are cut from similar thickness material and tack welded to the edge of the panel. This is done tightly so they can transfer heat efficiently and yet be easily removed. Let's see a weld being made with run-on and run-off tabs. After the welding is done, the tabs can be removed. It's important to avoid cold starts at the beginning of the weld. There are two common methods used to help control cold start. The first is tailing into the weld joint. By doing this, the weld is started off the weld joint and moved or tailed into the weld joint. The weld area is heated and weld penetration is better than if the weld was started on the joint, similar to MIG welding steel. Notice the start of the tail is cold. This is evident by the tall, ropey weld bead, but as the weld moves closer to the joint, it is starting to flow out more and flatten a bit. The other method of managing heat at the beginning of a weld is to strike the arc on the weld joint and not move until the weld puddle stops building up and starts to drop and flow out. Notice the start of the weld does not appear as cold as a tail-in weld, and also will not require as much finishing or grinding. Another welding technique that can be used on aluminum is the skip technique. The skip technique uses multiple welds randomly staggered along the seam to help control heat. When working with skip welds, it is critical to use a wire brush on the joint between welds. If contaminants and soot are not removed, a weld will have porosity and may have poor penetration. As more welds are added, a continuous-looking weld seam begins to appear. When ending an aluminum weld bead, a crater will occur. A crater is typically a low spot at the end of the weld with a dimple in it. This dimple is a prime location for cracks to start. To limit the chances of cracks from a crater, fill in the crater. After the initial weld is made, the arc is restarted and momentarily welded in the crater area to fill the crater. This is done to remove the dimple and reduce the potential for cracks.